Okay, so we have our platformer function next. We're going to use the game skeleton class, which makes setup of a game pretty easy. Okay, it's going to take a game specs param, and which has a game width, a G width param, which is 336 in this case, a G height param, the game height, 144. Controller div ID is another param we can pass. In this case, it's controller. Okay, game scale is the scale of the whole game. We're just going to say 0, not to scale it. Game loop, what function is the game loop? And it's going to be this dot loop, we'll say. We'll create that method in a minute. And then initialization specifics. Okay, is another method it expects to call, which we will create this and call it this.setup. Okay, so that's the basic specs that it needs. There's way more specs, way more parameters that we could pass in the game specs object that we're going to pass to the game skeleton class. But that's all you need is that. So then we say Tabageos dot game skeleton dot call this comma game specs we pass to it. Okay, and that's our constructor. Okay, and we go ahead and define that on the for the prototype equals platformer. And we also extending a class in JavaScript is as follows: prototype. The prototype way to extend a class, you use object dot create and then say Tabageos.game skeleton dot prototype. Okay, and that's how you extend the game skeleton class. So now platformer is an extension of game skeleton. Okay, so that's pretty much all we need to do, and a lot happens because of that. Game skeleton is doing a lot. Okay, so then the only thing left to do is to define the setup method and the loop method. So let's define setup platformer dot prototype dot setup equals function, and the game skeleton class is going to call this for us. So even inside of this method, we still have this, which refers to platformer and to all of the properties and methods of the game skeleton class. There's a player property, this.player, and by default, player is not defined, it's null by default. So we need to define it. We're defining this.player is going to be equal to, in this case, we're just going to have it be a basic ninja. And we do that by saying new Tabageos basic ninja. Okay, and so its X location, we'll say we'll put it at 16 by 32. Its width is going to be 16, height is 16. The map is scene, is the map. Okay, and CA is the canvas animation that would animate it, but we're not gonna use a canvas animation. It's just gonna be a square. So we'll just put null for canvas animation. Normally scene would get cloned and player would have its own map that it uses separate from scene. But we don't need to worry about that. So we could say 1 for don't clone map. Delta time, that's all right. The tile width is 16, tile height is 16, map rows would be scene dot length would be map rows, and then scene 0 dot length would be the columns. Okay, use blip-map specific arrays. That means our map could have been set up with arrays inside of here instead of just numbers. We have not used arrays as the individual values. It's just numbers, so that's what that's about. Okay, so our player is a basic ninja. Okay, and we're not going to animate the players. We're just doing a real quick scene. So we're going to say this dot player dot direct canvas object equals this dot car layer. Car layer exists already. It's part of, okay, so there's a background layer, there's a car layer, and there's a display. The car layer is what the characters and the enemies get drawn on. You could draw on any of the layers you want to. If you draw on display, it's going to stay there on display. If you draw on the car layer, you'd have to keep drawing it for it to stay there. Car layer gets updated. By setting this property, we're telling it to draw a square, pretty much. And so this tells it where to draw the square. It's going to be on car layer. Okay, and so then also this dot player dot auto animate equals 1. Underscore direct canvas object is a property that's not documented. Really, when you set that, what's going to happen is it's going to fill rect on the car layer. And both of these have to be set. Both auto animate and direct canvas object have to be set. And then if both of them are set, a square will get drawn for the player on car layer. So if you wanted to change the color of the square, you would change the fill style of car layer if you, okay. But so direct canvas object is not documented. Auto animate is. Normally auto animate is for a canvas animation that we have as null for now in this example, but auto animate would, if there was a canvas animation, it would be calling the change direction animation method of the canvas animation for us. Okay, so auto animate also causes it to be drawn, also animate and draw, pretty much, not just animate it. Normally in the library, things with the underscore are private and you generally wouldn't even be using them, but some things you do, like auto animate, you might set. But in this case, we just did everything very manually so that we quickly have squares for everything for the player too. Okay, so that's just a better explanation of what's going on here with these two properties. When auto animate is set, it's inside of the move method that the animation is actually happening also. So when auto animate is 1, then also during the move method, automatically animations happen at the end of it to draw the player onto its defined canvas, car layer in this example. This dot camera type, we're going to say, is 1. We didn't have to declare that, but it means do move the camera. And then we're going to declare a variable that's going to define what colors to use when we draw the map. It's just an object. So 1 we're going to say is like bluish. Okay, so 0 is going to be the empty spot. We'll put that as white. Okay, these are just HTML color values. And 2 we'll do a little dark. Okay, so those are the color values, and the way we use that now, we're going to use the blitmap class, which quickly will draw onto whatever canvas, whatever we want it to draw on. So we're going to say draw squares from pattern. So the subject is what we're going to draw on. In this case, we're going to draw it on the display. We're going to draw the scene here onto the display. Okay, so the pattern is the scene. Pattern is that array. The square width is 16, and the color values are C values that we define there. Okay, so that method is drawing that scene onto display, which is always displayed. Okay, and then we're pretty much done. In this case, we're going to remove there's a HUD that automatically is made. We're just going to go ahead and remove that. Okay, this I'm just showing you everything in one quick thing here, and then we'll get into the more involved platformer in the next one. Okay, we'll start with the sprite sheet. See, in this one, we're not using a sprite sheet at all. We're just telling it to draw some squares where we want it. The player will be a square, and the map is more squares, and we quickly set up a game like that. Okay, so the next method we're gonna define is the loop method. Okay, and this method is going to get passed a TS, a timestamp. Okay, the game skeleton class is passing the timestamp into this method. We're going to tell it to move with the, based on the controller buttons. Okay, so let's just CB the controller buttons, just so that it's not a long thing that we retype, is going to be this. Right, and in every method we have this, which refers to the game skeleton class and the platformer class. Okay, so we say this dot controller dot buttons. Okay, so that we're just doing that so we don't have to repeat this dot controller dot buttons over again. And then this dot player dot move left cb dot left cb dot right, cb dot up, or let's just write cb dot a, we can do whatever, down cb dot down. Okay, and all those we don't have to pass those, and that's it. Okay, and then to start everything we say new platformer, and that's really it. Okay, and then when we run it, we save it and run it. And that's what we got. A square that can double jump. Oh, part of it didn't get drawn for some reason. And the twos are not dark. Oh, I see. I forgot the hash right there. Okay. Let's see. Right, and see, no server, just refresh it. There. Okay, yeah, I forgot the hash. Okay. That's how quickly that's 70 lines of code, 77, including the HTML and spaces. Okay, and then we're going to expand all this out to create a melee attacking platformer with complex scenes and enemies and all that. That's where we're going next. But this gives you a basic overview of the setup, right? So we set up with Notepad++ and the code completion, JavaScript XML file that we got from GitHub, from the Tabageos GitHub, and then we included our JavaScript, and away we went. We can immediately program with Tabageos, make a quick game and run it, and there we go. Okay, so that's the basic overview of using the Tabageos to make a game. Right, it's set up to where we can make it quickly.